in Android, we're going to need two things. We're going to need the Java file for the code, and then we're going to need the XML file for the layout. And the XML file is going to hold all the graphics and all the buttons and all the stuff. And so let's start with an XML, or let's start with a Java file. So I'm just going to do this by hand, right? I'm going to right-click on my project, and I'm going to say New Class. There's lots of ways I could have done this. I could have copied and pasted from another folder or something, but I'll just say New Class. And let's call this Bubble Screen. We'll just say Bubble. And you see here it says Superclass. We could leave that for now, but generally you're gonna base that off of an Android activity. And so let's browse for a superclass because we're working on activities, and activities are screens. So we'll just make a class called Bubble, and I didn't need to use the Eclipse environment to do that. I just chose to do it that way. We could have used an editor and drug it into our folder and refresh the project or something like that. But here, this is just a generic class. Because we're in the BuzzTouch world, we probably want to extend the BuzzTouch base class instead of the activity class so that we can take advantage of all that other cool stuff. So let's look at one of the other screens to see how it did that so that we can kind of cheat a little bit. And if we go to, I'm just going to open up a folder here. If we go to this bug splat source, and we look at one of his screens, there's none in this project. I'm just going to open up a screen in a text editor and kind of show you what we're talking about.
I'll say, not to interrupt you, but Joe is actually following this very closely. I wonder if we can do anything to make a bug that goes behind a jar, or make the bug do like the bubble does or something like that, and then Joe actually could have
Yeah, you could do all kinds of that stuff. Totally.
That actually use in his project. That would be, I don't know, maybe you can actually move the bug, and the bug falls, like instead of having the bubble go back and forth, have it go back and forth and then fall into a hole or something like that, or I don't know.
Try to steer
like a maze game, I don't know.
Try to steer the bug back to the trap or something.
Yeah.
That's a cool game. That'd be a cool game. You can call it like what was that bug zapper, bug killer commercial where they squirted the roaches and they died? The Roach Motel. You can try to drive the bug into. You can try to steer the bug back to the motel.
Whatever you do, I think Joe's pretty committed to getting into his game. So if you can
awesome,
get back to
awesome
game, it doesn't have to be bugs, because we're going to change the artwork. It could be butterflies. It could be
yeah.
Could be mosquitoes. Could be, I don't know.
Yep. Okay, so
I don't know.
Totally. So all I was demonstrating here is I'm bringing up a full-on, complete, complicated class file to show you next to my Eclipse project. We just made a blank one, right? So instead of extending the activity in our blank one, the generic Android activity, we're going to extend the BuzzTouch activity base, and that's going to give us a lot of resources that aren't available in our other. Somebody's staticking. I'm not sure who that is. Oh, cool. Chris has got Junior with him. Hey, buddy. I love it. He's waving. He's future coder. That's cool.
I muted you, Chris.
Okay, so.
Okay.
Yeah, totally.
I'll mute you again, so you don't have to worry.
There you go. So back to our example, we have a basic class that's extended the BuzzTouch class. And we know that our graphic here has what we call a bunch of parts. A bunch of parts. So let's just start attacking these images for now. So we have to get, in programming world, we have to get what's called a reference or a pointer to each thing on our screen that we want to manipulate. So if we want to have an image view called background or something like this, we're telling Android what kind of thing this is. It's a background. And we're going to set it to nothing right now. We're just declaring a bunch of stuff. So if we have an image view nav bar, you might be asking, why is this red underline already showing here? That's because, and this happens all the time in Android. And the trick is just hover over it and pay attention. We're saying to Android in Eclipse, in Java, hey Java, we want to use this thing called image view. Well, what the heck is an image view? What is that? Well, the code doesn't know what that is because we haven't imported any of the logic related to anything Android associated yet. This is just a generic Java class. So if we hover over this and we import the image view parts or components or logic, you can see now that we can use this thing called image view because we imported it in there. So you can't just go throwing references to things that Java doesn't have any idea what they are without oftentimes importing the class files, importing the necessary libraries, they call them. And so pretty cool now. We imported the Android.widget.image_view. That means we can use that thing. So we have an image view of background. We have an image view nav bar. We have, what else are we going to have? An image view bubble. We have an image view. You know what? I'm not going to call that bubble because our class is called bubble, and that's just doesn't feel like a good idea. Let's call this ball or bubble. Bubble indicator, something like that. And then let's put our image view bubble bar, right? So these are just what we call in Java fields, what in iOS you would call properties or variables or, you know, instance variables, all different kinds of terms that basically just mean variables on our screen. And we want to get references to each one of these things later on in our code. So this, in our other example, I've got it side by side on purpose. You'll see this is where we're declaring all of those things. So we're declaring some strings, we're declaring some buttons, we're declaring all kinds of stuff. And then later on, we're going to access that stuff. So I'm just kind of running this one side by side so we can see how we're doing this. So speaking of buttons, we also have a button. Let's call button 1, button 2, and button 3. For our nav bar buttons, right? Actually, let's call this nav button 1. And we're going to want references to these buttons. 1, 2, 3 later in our code. So Susan, pop quiz, why is this underlined?
Well, because you need to import the button class.
Perfect.
Which is coming, but that brings up a question though. So the image view comes from Android, but the button class comes from something that you have in the core code, right?
No, look at the import. I'm just telling Android I want to use Android widget button.
Okay, it's the Android thing.
It's just a button.
Not even from your, it's not from your core.
And the lesson there is many errors that everybody freaks out over are a simple misunderstanding. The source code doesn't know what you mean. Mm-hmm. The compiler doesn't know what you're talking about when you say button. Mm-hmm. So we're telling it, yeah, when I want to use a button, I'm talking about one of these things, an Android.widget.button. Mm-hmm. So this, the technical term of that is this object is going to subclass, I mean, this is the parent class of this object. Mm-hmm. That's technical terms. So anyway, we've got some parts on the screen. Now we have 2 more buttons down on the bottom. We've got button, what did that other one do? What do you think this one here does?
Oh, I'll check here.
Oh, you got it on your phone?
Yeah, it does. It's something. No, I'm not quite sure what it does. It's something with not sure what it does.
Let's call it the center button. Maybe it centers the bubble or something. I don't know.
Oh, I think it changes your point of reference for what's leveled.
Okay, so reference button.
And so it changes that level now suddenly could be this instead of this.
Exactly. Doesn't matter, but you get the point. So let's stop there and let's just decide. Oh, and then we have, what's this degrees thing? That's a text field, right? Or is it a text field?
No. It shows you where you're at. It shows you you're at whether you're level or not. It shows you a number that tells you how far off you're off.
Yeah. So our text view is a different kind of thing, and let's stop there and just discuss for just a second what we've done. We in our code are saying that we're going to want to access a text view that we've named degrees. We're going to want to access the background image, the nav bar, the bubble indicator, that's the oval, the pill, the bubble bar, the nav button 1, nav button 2, nav button 3, reference button, and hold button. Those are just parts on the screen.
Mhm.
So we have to declare these in our code as the appropriate type of object so that we can then manipulate them. And different types of objects are going to allow us to manipulate different types of things. For example, a text view, you can set the text. An image view, you set the image. A button, you set the background image and the button click listener and all the different things related to a button.
Mhm.
And so we have to tell Android and Java what these things are. Okay, so that's all we did. Doesn't know where they are, doesn't know how to find them, we just did a little bit of setup. So now we don't have a XML layout for this bubble class. So let's go to the XML layout, and we're going to go to Resources, we're going to go to Layout, and we're going to make a new layout. Same thing I did before. I'm just going to New Android XML file. I'll just call this bubble screen .xml, right? The root element, there's a bunch of choices here. I'll explain that after we open it up in XML, but we're just going to do absolute layout. So now we have a layout file that is where we're going to describe or tell the operating system how to display everything on the screen visually. Now, I'm going to take a little break here and I'm going to go off on another tangent. You don't have to use layout files, just like you don't have to use nib files in iOS. But as it's turned out, as a developing community, generally speaking, you use a layout file to put all your UI parts on, and you use a nib file to put all in Android, and in iOS you use a nib file to put all your layout parts on. But it's the same idea. And so this very elementary, I guess, in my mind, little view here on the screen is Eclipse's attempt at letting us have a graphical way to lay out all of our widgets. It's not nearly as good as Interface Builder, in my opinion, but that is the intention of this tool, is it allows you to drag things onto the screen to then drag them around and do all kinds of stuff. So this palette right here has all kinds of things on the screen. So you see how I'm now your palette might look different than my palette. You know, the way that these toolbars are laid out. In fact, I don't like it like this. I want it over on the side. How do I move this thing? Anybody know how to move a palette? See how it's pinned? I can't remember, but you can move these. You can move these tools around. I want it over on the side. Oh well. So the point is, we already know what kind of things we want to drag to the screen, right? We wanted to add a text field. Why can't I see this? If you guys know how to move my little palette to the side of my environment, I'd love to know.
Oh, I gotta unmute Chris. I bet Chris will know.
Chris, do you know? I could figure it out, but I'm frustrated right now.
You can't just.
How come I can't see my little?
Sorry.
Oh, there we go. Just trying to move this palette bar over to the side. Oh well, doesn't matter. Point is, we've got text fields, and let's just drag one onto our screen. See how I can just drag it down here? We want to do an image for the background. Okay. We want to do I'm just going to give it a generic image right now. Oh, you know what? Can I add? I'll just do blank for now. We've got an image. See, here's an interesting thing. I'm using what's called an absolute layout, and it's telling me I shouldn't be using an absolute layout because that's deprecated. Oh. So let's choose a different kind of layout. This is our image. Let me go to my code. See where it says absolute layout? I'm going to change this to a relative layout. I'll explain this in a minute. This is the root element in our layout. It was telling me that an absolute layout is no longer allowed. So anyway, all we have is an image on the screen, and this is going to be our background image. So I'm going to give it an ID over here. We'll call this BG. All I'm doing is using this tool to help me create XML. We could do this manually like I used to do, and still do actually, in this XML, but we're doing it graphically. So we had a background. We need a circle. Oh, no, the circle's part of the background. My correction. We need a, what do we need here? So we need a nav bar over here on the right. That's another image. So image. I add the wrong. Just dragging little parts on here. Okay, so here's our little image. We'll call this nav bar. Why is it not?
You mean the bubble bar?
No, this is, I'm trying to make it tall. Mm-hmm. This is the part of the layout that I get frustrated with, but let me make sure that our layout is fill parent. This is a really confusing concept on doing layouts. In fact, let's talk about it right now before we get too carried away. One of the things in iOS that's fundamentally different than Eclipse and Android is the way that things are laid out on the screen. iOS uses this concept of a frame. It's a four-cornered rectangle with an X and a Y, a width and a height. And everything's in a frame. And in my mind, it's much easier for me to get my head around this. I don't know if everyone else agrees with that, but it's pretty simple. It's a grid on the screen. You want a frame. You put the X, Y coordinates and the width and the height, and it works good. Android doesn't use frames. Android uses a layout. And this kind of comes from the Java world from a long time ago when you were using, has anybody ever heard of Java Swing? That was a UI tool that you could use, and a language actually that you could use to do Java markups, like in the BlackBerry days and all that kind of stuff. But anyway, so in an Android layout, you have these things called, or in an Android UI, you have these things called layouts. And different types of layouts behave in different types of ways. So I'm using a relative layout here like this, but there's other types of layouts like linear layouts and table layouts, and what are some of the others? I can't remember. If you go to Google, just for fun, and you search Android layout types, you're going to see lots of different kinds of these layouts. And the types of, so you have linear, relative, list, grid. The type of layout that you use determines how the parts that you add to the screen will behave as the device grows and shrinks and moves around. And so it's important to understand that the type of layout you use will directly relate to how the things magically move around when you don't expect them to sometimes on the screen. So the easiest way to explain it is a linear layout. If we were using a linear layout and putting all of our parts inside of a linear layout, then it's kind of one by one, button, 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 button. It's almost like a list. Things will flow down the screen. You can do linear layouts with a horizontal flow, but the default is a vertical flow in a linear fashion. So those are very common when you're doing layouts, but not necessarily very flexible, Because if we look at our screen type here, we're not really trying to say that first you have a label, then you have a button, then you've got a image, then you've got a bubble, then, you know, it's not flowing down the screen. It's kind of all over the place. And so that's where this term relative layout becomes useful. So relative layout is this container thing that we're talking about. And the cool thing about relative layouts, and also the challenging thing, it's not very easy, is everything now on this screen, every part, this one, all these little widgets that we're going to use code to talk to, they're related on this, they're laid out on the screen relative to each other. So it's hard to kind of understand, but like this button relatively is underneath this button. And this button is relatively at the, you know, floated to the bottom of this parent layout. And this layout is relatively floated to the top left corner of this layout. And this is, and eventually you kind of get kind of good at it. It's kind of hard, but you do get good at understanding how these things are going to kind of float around the screen. So with that said, here's where it gets really challenging. With that said, I would doubt highly, let me find our other graphic. Where's our other graphic? Here it is. I would be highly suspicious that this level app has things moving around as the device rotates and it's probably locked down. So that's kind of an absolutely positioned thing. I would assume that the only thing on this level screen that's going to move is this bubble and this little nav bar over on the right. And so that's where it becomes kind of tricky to adjust what Android calls the layout parameters. So a layout parameter is kind of like an iOS frame. You apply a frame. Let's say you were in iOS and you used Interface Builder and you drug a button out on the screen and you said it was 50 pixels high by 200 pixels wide, and it was at the top left corner, down 10, over 20, or you know, over 20, down 10. So that frame has 4 coordinates. So a layout parameter object is in essence 4 coordinates. So you can create a layout parameter and then you can apply that to your widget. But that kind of this is just my mind, that kind of goes against the whole concept of what Android's telling us with these flowing layouts. So as soon as you start fixing things to the screen, it becomes very challenging to accomplish what you want across a bunch of different types of devices. So that's why. Go ahead, Sue.
Couldn't you just like have it be relative, but be relative to the center, so that you would just take this, so maybe have the background be you know, the background, but the circle be always be centered and always be the same size no matter what size device you have. So it would be
no, you're exactly right. So what ends up happening is you get very, very creative with I mean, a lot of the effort is not Java programming. It's how in the heck am I going to keep this flow right just so it looks right, which has nothing to do with interacting with it necessarily. It's not an easy concept. And so a lot of the most skilled developers are the guys and the gals and the folks who kind of quickly can see from a creative idea, in this case a bunch of art, how that might be done in a layout file. And it is a skill that's worth honing and practicing, because it's not easy to do. And only once you get it laid out can you then begin to manipulate it. So that's kind of the layout, my little layout rant. But really what you're going to look at, what you're going to end up with, and I'm just going to cheat and copy and paste some stuff because it's so much faster. What you're going to end up with is a bunch of widgets in your layout. One widget for each thing, quote unquote, thing that you want to talk to. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things in our code that we want to reference in our layout. Saying that the other way around, we have 10 things that we want to have 10 things in our layout that we want to reference in our code. So we know that we have one text view, and it's called degrees. That's the name of the Java field. I like to name the layout widgets the same thing as I name the Java fields, but we have one text view. So I'm going to copy this. I'm just going to put them in order, just like I did on the other screen. This is not an image view. This is a text view. Okay, so it does not have a source because it's a text view. So I'll get rid of the source. and we're going to call this degrees. Okay, so there's our text view. I'm going to cheat a little bit, and I'm going to copy all of these over to my layout, and then I'll delete them in a minute, and I just do this as a little cheat sheet so I can see which ones I'm going to make. So I made the text view. Cool. Now I want to make an image view for background, nav bar, bubble indicator. So 1, 2, 3, 4 image views. 1, 2, 3, 4. So this is named BG, nav bar, bubble indicator. So this one's named BG. This one's named nav bar. Do I have a capital there? Yep, nav bar. I'm giving these IDs because without IDs, we won't be able to access them or reference them in our code. We have to give them IDs, bubble indicator, and then bubble bar.
Hey, Dave.
Yeah.
David,
I'm listening.
with those IDs, can they be different or similar across layouts, or does it have to be a different?
Yeah,
ID
that was
for
going to be
the
my
entire app?
question.
That's a great question. So they do not, they can be similar across layouts. They can be named, it's all they need to be is unique to this layout. So you can have this layout with all the same parts as another layout with all the same IDs and everything, as long as that layout is a different file.
Because you only have one layout per class. Right?
No, you can use a bunch of layouts. Generally,
One ID per layout, multiple layouts per class.
exactly.
How
So
would that work if you had the same ID on 2 layouts and had both layouts in the same class?
then you would have a problem.
Okay.
Yeah, so if you load it into, and that's a great question actually, in Android, and I'll pause there for a minute. In Android, you have this concept of inflating a layout. Inflating a layout in Android is kind of like that concept in iOS where you use that built-in load class from nib name. You see that all the time in the training and online and examples. You'll see that load class from nib name. I've never really been a big user of it in the BuzzTouch projects, but you do see that online a lot. And what that does is it tells Interface Builder, it tells iOS, hey, go get this nib file that has all my layout parts on it and just kind of unpack it all, right? Or parse it out, figure out where this stuff's all supposed to be on the screen. So in iOS, that's called load class from nib name. In Android and Eclipse, that's called inflate. So you inflate one of these XML files. And you do that in Java. You say, hey, Java, go find this view, or this, excuse me, go find this layout. It's this XML file thing over here, and then inflate it. And when you inflate it, now you can get a reference to all the parts that are inside of it. If you don't inflate it, then you run into trouble because you're thinking, hey, there's a button in there, and Android and Java don't really know that you have a button in there because you haven't told them to unpack it. And so it's kind of interesting actually how they do that, and it makes perfect sense. The reason that they do it that way is think about the operating system and memory and battery and power. If your app has, say, 50 layout files, and some of them are really complicated, right? They got crazy United States maps and the world map and all these 100 images, all this stuff. Well, you wouldn't want to unpack all that and parse it all out and understand it all if you were an operating system and keep it all in memory, which is the key, until it was time to use it. Right? If the user never went to that screen, there would be no reason to ever unpack it all. So Android doesn't do it that way. It keeps a reference, and interestingly, as we go off on a little tangent here, remember our R folder that nobody seems to be understanding what it is? This, where am I going here? Hang on. Oh, generated. This r.java, this maintains a list of everything in our project, a little pointer to it, so that when you do inflate it, it knows right where to go. So every time you add an object to your project, that's what that R thing is. Those are called resources. So you're adding things to your Android project, and that's why you'll see crazy errors and stuff when you drag another person's project into your project, or you try to marry these two projects, because the compiler's like, wait a minute, I'm trying to keep track of all this stuff and I don't understand. And so that was a little bit of a tangent, but that was a great question. So you'll find Objective-C, Java classes like this that we're creating that will unpack tons of different layouts and add them to the screen. That's completely okay. Most of my history and background and approach has been I try to keep all my stuff in one screen, in one layout file. I don't know if it means I'm lazy. I'm not really sure, you know, where that came from. If it was maybe early days of Android when that was kind of common, you know, before we had fragments and all these other new concepts. But generally, you have what you'll find is most activities will have like a base layout and then maybe another one on top of it or something like that. And you'll see. Let's go back to this code. I know we're bouncing around a little bit, but let's jump to that because we're talking about it. The onCreate method of this PDF doc screen, now that we just had that conversation, this might make a little bit more sense to you. Hey, Android, when this thing is created, when we launch this screen, you're going to find that there's going to be a linear layout, and we're going to name it BaseView, and it's inside this resource with the ID BaseView. So that's kind of a complicated way to say that's just a pointer to that view. And then remember we talked about inflating? We have this inflate this screen's layout file. So because this is a BuzzTouch screen and it's so similar to all the other screens, this points to the base view in the base class that all the views borrow from, and that's how we can use the background image and the background color and all that standard stuff that BuzzTouch uses. So that's where the base view is. But what we do is we inflate another view, in this case called layout screen PDF doc, and then we add this thing that we inflated to the base. So I'll rephrase what I just said. The BuzzTouch plugins generally work like this. There's a base view that's blank, but it has a bunch of parts like these, right? A bunch of parts in it, a bunch of widgets. It is exactly right here, the activity base. There's the Java file, and there's the XML. This is the base view that most, I should say, not every, BuzzTouch plugin uses. And these are all empty, waiting to be talked to. So our class gets a reference to this base view right here. And I'm back to this PDF class. We haven't got to this in our custom class yet. So it says, hey, let's get a pointer to this thing called BaseView. And then because we know as developers that this BaseView contains a bunch of parts, let's look at those parts. You've got a frame layout, and then inside that you've got a relative layout, another relative layout. They have IDs, background solid color view, background gradient color view. Got another relative layout with a background image box, right? And you got an image view inside of that. So then you got a linear layout. You've got all of these parts that are just kind of sitting there empty. But because we know they exist, and because we got a pointer to them, we can then say, hey, View Utilities class, go ahead and update the background colors for this screen. That basically means go to that layout and change the properties of each of those little widgets that we know are waiting for us. That's kind of the idea. And then after we do all of that, let's inflate the XML view for this plugin that's unique to this plugin and lay it on top of that base view. That's the logic here.
So we need to make sure that our IDs and our layout don't conflict with the base layout.
Exactly. That's exactly right.
So
and when you're programming
our initials on the IDs,
you could. What you'll generally find, and the reason why it hasn't really come up a whole lot, what you'll generally find in Eclipse with the SDK is they won't let you name something again. It just won't let you do it. It'll be red and ugly, and it'll yell at you, and it'll be like, what's going on? And you'll quickly discover, like, I see. And so you're not gonna conflict. I don't think you're gonna conflict, although that brings up a great point. This container view right here in the activity base, it probably would make a lot of sense if we named it something like that. Right? If we were forward thinking enough when we made this originally. It would have probably made more sense.
We have to add this to like the requirements that not only do all the file names have to be unique and the class names unique, but also all of the IDs have to be unique.
I wouldn't worry about that yet. I mean, I think there might be some edge cases. Yeah, there's already too much to understand. I think there'll be edge cases where that might happen, and Chris does bring up a great point.
Yeah.
But so far, it's just not been a problem because people aren't naming things like, background solid color view, stuff like that. And so, but I do agree with Chris's logic there, and that spurred kind of a little moment there. It would have made more sense. You notice how all of our Java class files are VT underbar, right? It's easy to organize all that stuff, and that's intentional. So that when you're browsing through things, you can see like what's core project stuff and what's not. So it would totally make sense that the very few layouts that we use, there's only a few of them, would reference, get renamed. But there's a lot of code that talks to those things, so maybe it's down the road. It's on the wish list. Okay, so let me close this, and we're going to go back to our bubble screen, and we're going to keep trugging along here. We have the degrees thing done. We have the background thing done. We have the nav bar, bubble indicator, and bubble bar done. Bubble indicator, bubble bar. So we're just laying these out. And then we need to add 1, 2, 3, 4, 5 buttons. So these buttons are called nav1, nav2. Okay, cool. So I'm going to call this, copy that, and these are buttons. So buttons have different properties than images, so we're not going to have a source for a button. So we'll call this one nav button 1. And you might be asking yourself, well, where are they going to be on the screen? We don't really know that yet, and I'll explain it to you. Because that really is the challenging part. Nav button 2. Nav button 3. I feel like I posted more than that. 1, 2, 3. 4. The 4th button was called ref button. The last button was called hold button. Okay, so now our layout is quote-unquote done, but it's not going to look and lay out like we might expect. That's because we just cut and pasted all these. We just generically threw the objects on the screen. They all are basically using the same height and width. I just copy and pasted all this. And so we would then want to go back and start changing the width and the height and the layout properties of each object so that it's relative to the objects that you got to figure that out, how you want to lay this stuff on the screen. And again, you can try to use the graphical layout tool to do that. You can see that we just put a bunch of blank stuff on the screen here, so you can't really even see it. There's all kinds of parts here, though. We just chucked it all on. They're all the exact same size, so it's kind of having a hard time understanding, the difference between where they're located. I don't think now is the time to actually go into this whole science of moving things around on the graphical user interface tool, but I will say maybe as our homework project we all spend a little bit of time using this to try to see all you're doing is just dragging things on the screen and giving them IDs and giving them properties with the little palette. That's all you're doing. So let's go back to the code and talk about how we manipulate them in code and assume that we can figure out our layout down the road or whatever. But the point is we've got all the parts on the screen, and I'm going to go back to this class file, and I'm going to show you that after we declared all of the Java fields in our class, we then have to do some things that Android requires. We have to have an onCreate method. We have to have a certain set of lifecycle events. And so let's just go ahead.
David, before we get too far into this, if you don't mind if I back up for a half a second or so.
Totally.
With respect to our base layout and the layout that we create for our screens and such, should should I look at that as nesting or layering, or does it really matter?
That's a great question, and the answer is you can. Both of those words, kind of to me, mean the same thing. Okay. So whatever one of those you're more comfortable with, but they're both absolutely appropriate. It is nesting or layering. That's exactly what it is. And so in my mind, it's the first step. And let's get to this step real quick. Okay. The first step is.
I think of layering and nesting as two different things. Should I be thinking of them as the same thing?
No. I mean, if you were to draw out a nesting thing, I think you and I would draw the same thing, right? We would nest levels like in XML.
Right.
And if we were to layer it, we'd probably do it on top. So in the one after the other. So you're right; they are. You can perceive them.
I see where you're going on that. Okay.
But how you're adding them to the screen can kind of be perceived as the same thing, because sometimes you add them to the screen under something or on top of something, and sometimes you add them to the screen like literally below them. Like nesting to me would be like literally on the screen, 1, 2, 3, like a list of things.
Okay.
So depending on how you mean, let's go 5 more minutes, and maybe this will make more sense. Because in my mind, we layer the custom layout for this screen on top of the base layout, and then that layout has a bunch of stuff nested, I guess.
Okay.
Hard to totally understand what we mean, but I'm going to comment all this code out one at a time, and we're going to get back to where we were, and then we'll go from there. Okay, so I just pasted a generic onCreate method in here. Why is bundle underlined? Back to you, Sue.
Always calling me too, but
I'm always calling on you.
I know. So bundle, you must have to import bundle then too.
Exactly. So bundle's not imported, right? So this happens all the time.
Let's stop there, because this is actually where I get stuck in Android a lot. Oh shoot! But okay, so
no, that's okay. I just imported that.
You see, you got something missing, and then you see that list of choices.
Yep.
You usually need to import the class, I guess, as your most common likely. But sometimes there's other things on there too. So sometimes I've imported classes and it hasn't been the right thing. So.
Yeah, let's go back and show you exactly what you just said. That makes perfect sense. So this class file right now has no knowledge of what a bundle is.
Mm-hmm.
We've read somewhere online, we read a book, we talked to this guy named Dave. He thinks this bundle thing's like a built-in Android deal. What the heck is a bundle?
Yeah.
So we're like, well, it's not something I made myself. How come Android doesn't know what how come Eclipse doesn't know what this is? Yeah. Because really all this is the compiler trying to help you.
Mm-hmm.
Right? If you were in a text editor, nothing would be underlined.
Yeah.
It would just crash when you ran it.
Yeah.
And so if we hover over it, Susan asked, what do I want to do here? And my tool is saying that I think that there's 8 quick fixes available.
Mm-hmm.
Well, it's Eclipse's best attempt to try to help you identify where you're having a problem.
Mm-hmm.
So it's saying, in most cases, I think you probably just didn't import this thing, this library that I need to know about in this code. So it generally puts that at the top of the list. But maybe you really do want to create your own class called bundle, which it would then yell at you because you'd have to subclass the Android bundle and all that kind of stuff. But you could do that. Maybe you want to create an interface. Maybe you want to create an enum. If you know Java, these make sense. If you don't, it's generally because you didn't import it. And so that's kind of the rule of thumb there. But these are just shortcuts to help you try to help the compiler understand what you're doing. So when I selected that, look up at the top of our code here. We've now told the code we want to use a class and all a library, excuse me, or a parent class. There's a little difference there, but the semantics are important. We want to extend, Android.operating-system.bundle. Just like we want to extend Android.widget.button. And widget.imageView and widget.textView. Now we only need to import these once, and we can use as many text views as we want. But we got to tell the code to do it. And if you look at a project example, go ahead.
When we do that, is it literally bring in that entire class file into the code?
It doesn't bring it in, but what it does is it points to it, and that's the whole idea with this SDK. So what ends up happening is you download the Android SDK from Google, and they're saying, hey, this company called Sun a long time ago made this tool called Eclipse. Let's use Eclipse to help our Android developers write Java. So let's build a little plugin that works in Eclipse that's kind of Android-centric, you know, and it's got the little man, and it's got a way to, you know, send a project to Google Play, and it's got a way to sign it with the Google keys, and it's got all these little cool things that you need to know how to do with Android. But you don't have to use that, right? You can compile this a lot of different ways. And so, but anyway, so Google makes this SDK. And in that SDK, they also say, here's all kinds of our latest code. And these are all what developers call the library. This is the cupcake 4 point whatever stuff. This is the, you know, 2.9 gingerbread. I don't know all the names and numbers, but here's the latest stuff that we have. And so that's all on your computer. It's not in your project. It's not in your app, but it is on your computer. And you've told Eclipse where it is on your computer. When you go to the properties for your project, you have said that my Android stuff, let me find it. My Android stuff, here's all the builders. I can't remember where the heck it is, but in here you've told it the path to your SDK. Builders, Java build path, I'm not going to, source maybe? Another little homework project. Somewhere in here you've told your Eclipse development environment where you put the SDK. So it's pointing at that. And then you've said inside that folder, I want to use this 2.2 stuff. Or I want to use this 3.0 stuff. So that's in essence what you're doing. And so you're not bringing it into your project, but you're pointing at it. But what happens is, what the development environment is doing is, since you pointed at it, it can then do things like put a red underline under a absolute layout that doesn't exist in that stuff you're pointing at.
Okay,
and it can
so
say, hey,
let me ask the question a different way.
Sure.
If I import some big complicated library that I don't end up using,
right?
Does it go through a bunch of processing during runtime? Does it sees that import and goes through that whole file as if it was a JavaScript import?
No, exactly. So the answer is no. If you import it, see what ends up happening is you're not delivering it. Here's another maybe way to explain it. You're not delivering it to the phone. If it's a custom library, then yeah, it's going to be in your app and you're going to deliver it to the phone. But if it's part of the Android world, the phone already has it. So it's not part of your project. And then when you launch a screen that imported that thing, and then when you actually use it, in our case, when we inflate this view, then yeah, it goes to the phone and it says, hey, operating system on this phone, what's the button look like? And it makes a button. You know what I mean? And what are the rules around what the developer can do to that button? Which is where you get crashes, because you try to access things that aren't available to you and you thought they were, and the development environment didn't do a very good job at capturing that idea that you're doing something you shouldn't be able to do.
So it only accesses that library when you get into the code where it says button nav button 1. Okay, I need to go to the library. Yep,
exactly. Yeah, great question. I love these technical questions. And so in the old days of computers and code sharing was kind of new, and object-oriented concepts and all that kind of stuff, you would literally have all of the code in your project. You'd have like 1,000 files, and here they were, and you could change them, and it's open source, right? You could manipulate what a button is in Android, and you would deliver that to the computer that you would launch your software on, and the computer was relatively unaware, really, and it relied on the operating system, I should say, was unaware of all this kind of stuff. But really, really early on, somebody decided that we shouldn't be shoveling all this stuff back and forth, and if the operating system knew what a window and a button and a slider and a pull down was, then we can just use it instead of delivering it every time. Which is why when you another tangent, but when you open up Firefox and Safari, I mean on Mac, Firefox on Mac, and then Firefox on Windows, the code's the same in essence, lots of it. It's developer says, you know, put a text box right here, so we can put our address in as a user. And iOS or Mac OS 10 renders that text box differently than Windows does. But still a text box or a window, right? Paint a window. You're not delivering all that logic to the operating system. It knows what a window is, so it just makes one. And it makes it its pretty way, you know, how it does it. So anyway, I digress. Let's go back to where we were. The point is we have an onCreate method that's in essence empty because I've commented all the code. There's the end of the onCreate, and there's the beginning of the onCreate. Does anybody know what super.onCreate means? Chris, you want to take a stab at that?
Huh.
Oh, Susan, all excited. She read something.
You're not calling on me for once, but actually,
yeah, I'll come back to you. What's super do?
Who's answering it? Am I?
Yeah, Chris's turn. Take a guess.
Okay. It's going to the whatever we've subclassed our parent class. It's
Perfect.
Going to that to pull it.
Yep. Perfect. Awesome. So because we subclassed the activity base, it's going to look to that class, and it's going to look for an onCreate method right here, and it's going to run that first. Oops, let me get rid of this layout. It's going to run that first because we put our line of code like right under that. We could put that at the end, you know, down here somewhere, and run it after all of our code, but we generally launch the super first. And then that onCreate in the super class or the parent class also calls super. So we'll come back to Susan. So what does that do in the base class?
Oh.
Mrs. Smarty Pants, I just read the textbook. I'll say it for you. We're climbing up stairs. We're at the top of the staircase, and we have an Android activity, right?
Yeah. Oh, we have to call
here. We extended the Android activity. We came down a stair, and we extended the activity in this base. We came down another stair, and we made a class called Bubble, and we extended the activity base. So 1, 2, 3 stairs. So we tell Android to launch this thing, the bottom stair, and it says, boom, onCreate. Okay, developer, you want me to launch the onCreate method in the stair above me? No problem. I'll do that. And when that happens, it's doing this. It's onCreate because you just told it to fire, and it's doing its super. So it's launching it up there. So all 3 of these onCreates will run. And it just kind of trickles down. And, you know, stairs is one way to look at it, but there's no limit to that depth. And I'd be interested to know, like, when does, and this Chris could probably, you know, this is related to some of his questions. You know, how many times can you do that before Android just says, dude, get over it? I mean, what if you subclass like 50 nestings deep, so to speak? That would be wild to do some math on that and see what the performance implications were on that. You know, it's standard to subclass stuff, you know, here and there all the time, but if you just kept doing it to an extreme, like in a loop 10,000 times or something, I wonder what would happen. It'd be kind of fun. Anyway, launch your onCreate, and then we have, I'm going to keep commenting this out as we move down. We have this thing called a BT Debugger. We all know what that is by now. It's just a class that I wrote that posts stuff to the console. But we didn't import it.
Oh, no.
So how come it's not red?
Yeah.
It's not red because we imported it in the base.
Oh.
And we've inherited everything in the base. Right? So you don't have to import things that you already got. That's just a simple way. Same thing with activity name. That's a variable. Activity name, right? It would normally look like this. String activity name equals, you know, Susan's activity. So activity name right now in this class equals Susan's activity. So we're going to, and then we overwrote the value of it right here. We started it here, and then we overwrote it, and then we put to the debugger the activity name and the name of the method, just so it's easier on us as developers. My point was, we didn't have to declare the activity name variable or field because it's in the base. It's a string activity name. It's the top thing. So we just put the activity name in here by hand so that our console shows us what we're, that helps us see what's going on. That helps us see what's going on. And then we print that to the screen. That's all that does. And then what we do is we want to get a reference or a pointer to our base view, which is in our base layout. I'm setting up our layout files next to each other here, just so we can, because we're going to jump around and see this kind of stuff. So we got base bubble, base bubble. Okay, so that's good. And then we have scrolling down here. See where it says base view? So our activity base file, our base layout file, has a widget in it. It's a linear layout. It's the whole screen. It's empty. There's nothing inside of it to speak to. I think that was Joe asking. I'm not sure if it was Joe or Smug was asking. You could have nested things inside of this. There's nothing inside of it. It's just empty. But we need a pointer because we're going to add a bunch of stuff to it. So we get a pointer to our base view. Why is linear layout underlined? We need to import that. So linear layout is the type of object. Base view is just what we named it. We've casted, that's a complex Java term to say this variable will always be a linear layout. So this is a built-in Android thing. Find view by ID, and then point to the resources.id base view. So there's our base view. This warning is we're not doing anything with it right now. So it's warning us. It's like, hey, you made a reference, a pointer to this thing, but you're not doing anything with it. That's why we get a warning. So after we have a pointer to the base view, then we can tell the the BT view utilities to trigger this method. Update the background colors for screen. It takes 2 arguments. That's why there's a comma here and here. If we went and looked at the view utilities class, we would see in the view utilities class those 2 arguments, update background colors for screen. So it wants an activity and it wants some screen data. That's the JSON. So we're saying the activity is this class is the activity, and this class's screen data, the JSON, is what I want you to use when you update your background color. And when you update, look at all this JSON and see if there's a background color, a background image, all that stuff. Actually, just the colors. So where does the screen data variable come from? Right? It's in our base class, screen data. Let me find it. It's in here somewhere. You'll find it right here. Screen data. What kind of thing is it? It's a BuzzTouch item. Everything's a BuzzTouch item. So it's just a bunch of JSON representing this screen, and that comes from, like we know, our JSON file. So go ahead and update your background colors. Technically, we could do that without referencing the base view, but on some of the devices, it gets kind of freaked out because I'm not sure why, actually. It wants a reference to, like, from bottom up or something. A long time ago, so I just learned that referencing the base view first before updating the background seemed to work better. But anyway, so then we're going to go here, and we're going to say, what the heck is this background image worker thread? That's just a background process that's running in the base to manage the background image crap. Excuse my French, but I don't like background image stuff in Android. It just frustrates me. But anyway, so if our thread's running and set the background image, then still doing generic stuff that all these screens do, but I'm pasting it one at a time so you can see it. There's a nav bar in all these screens in most cases. It's inside of a linear layout. So the nav bar is something we have to actually build you're not going to see the nav bar in the XML. And that's because not all the screens use a nav bar. So we customize it one at a time, but that's what that is. If this screen uses a nav bar, then we're going to take our base view, our pointer up here, our base view, and then we're going to add the view nav bar. So that is just like in iOS where we say add subview, same thing, same exact thing. So just stick it on top of this. And that to me, Smug is layering, not nesting. So if you looked at the view utilities, you would see what kind of a thing was returned by this method that, again, takes two arguments, the activity and its data, and it builds a nav bar or a blank nav bar or a whatever. You know, it constructs a thing with an image on the right and a button on the left and a title based on the rules in the XML or in the JSON, and then it returns it back. And sometimes it returns nothing. So if it doesn't return anything, then we just don't add it to the screen because it shouldn't be there. So we add the nav bar, and now we start to get to the custom code. All that's generic. All that's generic. So now what we need to do is we need to get back to that conversation where we're going to inflate something. We're going to inflate an XML file that we made for our bubble. So we need a layout inflator, which we got to import that. It doesn't know what the heck that thing is yet. And then we got to import context. It doesn't know what context is. I won't get into a discussion about context. That's a whole nother lesson. We got to import view. And then this here might interest you, r.layout.screenPDFDoc. You might think that you could just inflate bubble.xml, right? Doesn't that make sense? That you could just inflate the name of the view? That isn't how Android and Java work, and it's very, very frustrating. And so the reason that it doesn't work that way is, remember, it uses that pointer to memory, that reference in Android generated R, our generated R file that's got all pointer to all this stuff. So every time we use, lots of times in Android, it doesn't seem as simple or as logical as you might think, like trying to point to an image. You can't just point to resources drawable image.png. You got to point to r.id. It's very weird. And so in terms of bubble, we have to point to this thing with r.id. And now we name these are all the resources that Android knows about in that R file. It's kind of weird. So we're going to point to our layout, which we call bubble. Where is it? R dot, is it bubble? Bubble view? What do we call this thing? Oh, bubble screen. So we got an error there. Maybe I got my syntax wrong. Oh, it's r.layout, not r.id.
Okay.
Does that make sense? Notice there's no XML at the end, which would be more logical, but it's just not. So we've inflated this view. So at that moment, it's not on the screen, but we've told Android, go find this place, this file, and unpack it, and put all these parts into your memory, so we can now use them.
So,
but it's not on the screen.
Why didn't we inflate the base view?
Because the base class did that for us.
Okay.
Yep, great question. Great question. So we inflated that first, and we actually used a little cheater method. Check this out. See if I can find it. Let's see if I can find it. We used a little cheater method. The base class. I'll find it in here. See set content view? That's a shortcut. That's a shortcut that Android allows us to do, which tells it all in one fell swoop, unpack it and throw it on the screen. But each activity can only have one content view. So it's our bottom base thing. It's called the content view, and that's what we're adding everything to. So we're kind of not inflating it manually, but it is happening in the, you know, Android's doing that for us. So then what we do is we inflate this thing, but it isn't on the screen yet. So does that make sense to you, Susan? It's in memory, but we haven't added it to anything.
I was gonna say, you know, it's actually an hour and a half into this lesson here, and so I wonder, do people want to?
Oh crap! Let's finish. Let's add it to the screen, and I'll be done.
Yeah. Plus we have 2 other plug and code review sessions today, so it's kind of a long day as it is.
I'm sorry.
No,
I could just go and go and go.
I know.
All I was going to show you guys is.
Ask you one question. But yeah. We also need to kind of take a step back and figure out we have one more Android class scheduled just right after St. Louis, and then figure out, is this enough to get us going on our Android plugins, or? It'll
never be enough. We'll just keep exploring these ideas together for as long as we all want to hang out, and we'll go from there.
Yeah.
There's really no way to, other than, I don't know how else to say it, right? I mean, maybe we'll have a formalized class, you know, but that's a while from now. So,
there's lots of ways to handle it, but yeah.
Totally.
That we just like actually have people make appointments. We schedule meetings.
Yeah. I enjoy this stuff. So all I was going to show you was on 59.
You know,
we have a variable that we named this screen's view. It's a view type object, and we add it to the base view here with the add view command, and now it's on the screen. Now it's on the screen, just like you laid out in your XML, and then we're going to start manipulating. So good call. Let's end this. I've forgotten about. We have a 1 o'clock.
Nope. The next one is, I think it's 5 p.m. my time, 3 p.m. your time.
Okay, perfect. Because I've got some other business I got to take care of, and as much as I love you, I don't want to hang out with you on Skype 5 days a week, all day long.
I know. Yeah, it's enough. Enough is enough. It'll be 3.5 hours of time with that plugin developer.
Chris, what's your son's name?
Liam.
Liam?
Like Liam Neeson.
Awesome. Yeah. Cool. It's cool to see him on your lap. I remember those days. They're pounding the thing, they're reaching up, and okay, people, so nice to see you. I see all the names in the thing. I'm going to get going, and we'll just continue this. We didn't really do much other than, well, actually we did, right? We talked about, let's summarize this. We talked about how parts are individually broken up on a screen. We lay them out in XML, we reference them in Java, and then we manipulate them and do things with them in the Java code. But yeah, that's kind of the standard way. So no matter what screen you're looking at on any app in the Android world, even the ones as sophisticated that Susan was brought to our attention, that's what they are. Right? It's just a creative assembly of all these different ideas, and they're not as overwhelming as you might think. Because it always boils down to the artwork, always. So that's kind of the deal. But I'm going to sign off, and I'll see you next time, gang. And Sue, I'll see you in a couple hours.
I'll see you soon. Bye.
Thanks.
Thank you, everyone.